Hi friends, welcome back to Hi friends, welcome back to Tech with Shravan. Today I am going to discuss about most important topic in algorithms is like time complexity and space complexity. So first I will write down the what it is. Time complexity and space complexity. So suppose for every algorithm we should must have two properties we should follow. First is like functionality. So algorithm should functionality should correct. So first property is like correctness, I can say correctness. So we should say, so every algorithm is should work all its functionality correctly. So next I can say efficiency. So when in the terms of the efficiency only we will comes into the big picture of time complexity and space complexity. So the correctness is like it is related to the functionality part, and efficiency is main picture. So efficiency is something, but our time complexity and space complexity is the matter here. So we will see to deeply now. So you need to remember for every algorithm, if you write first, we need to decide the correctness and the efficiency. Now if you see, suppose if I have given two problems, what is the problem statement is like search a number, search a number in for search a number for 1000 elements. So suppose I I said like please write a program for searching a number for 1000 elements. So mostly suppose two programs I got. So first one is like it took 1 second. Second one took second program 100 seconds. So the output is same. Output is like it is same whatever the number I want to search. So it is written the same number, but the output part is like one program is taking 1 second, another program is taking 100 seconds. So here we need to take the efficiency matters here. So both are correct, but how efficiently an algorithm behaves when size, if here size is 1000 elements. So for 1000 elements, how algorithm is behaving. So we need to set that one. So for 1000 elements also efficiency should be the 1 second or 2 seconds, not 100 second, right? So this we can say. So not only the time here, like application, how much growth it will have. Suppose if it is taking 100 seconds means internally it will run so many loops. So at that time it will time automatically increases and space automatically increases at that time, right? So we need to consider these things like, so here I will write the what exactly the what is the time complexity means. I am writing here, note down. So time complexity means how the number of operations, here we need to tell out how number of operations grows. What about the space complexity? It's deal with the memory, correct? So it deals with the memory of the application. So our how much our application takes that memory. So how much additional memory the algorithm needs. So here two things we need to discuss here. Time complexity means how number of operation grows. Space complexity means how much additional memory the algorithm needs. So that doesn't mean, see, time complexity doesn't mean it's exactly 2 seconds, 3 seconds, not like that. How operations are good, that is the based on that one time complexity will be, we will calculate. So at the, see, if you say, see how suppose if you only one iteration only, suppose if I am giving like, suppose here n is the input size, you need to remember n is the input size. So here we will declare as like O of n. Suppose if it is a O of n means it's a linear, it is a propagation, like we can say if it is a operation, number of operations grows approximate proportion to the input size. So if it is a n, so n operations it has performed, like, so we are dealing with the time complexity now. So we will discuss about the big O. So we will discuss big O notation. Here we have big O notation in time complexity and space complexity. We will discuss later about this one. First you need, you understand the basics about this one. So here if you see this one, suppose if an array contains, suppose int, let me change the color, I think it's not good. Okay, so suppose if an int array, so in Java you can see any language 1 2 3 4 5. So if it is a array contains 5 elements, what is the input size? We can say here n equal to 5. So this is, so when we say O, so if it is a array contains 100 elements, we can say input size is 100. So at this time we can say O of n. So this is a O of n, means number of operations grows approximately, I can write here, number of operations grows approximately in proportion to the input size. So this is what we can say, it is like O of n means number of operation goes to the approximately the input size. Now we will see, now here you can see the time complexity, first one. So you can say time complexity. So if you see time complexity, so suppose you first start with some easy things. So suppose I have two numbers, into a equal to 10, into b equal to 20. So into c equal to a plus b. So how many times do this operation need to execute? So only one time, right? Suppose if you give 1000 elements also, 1000 operations also, suppose if your input is 10, input is 100, 1 million also, these statements executed a fixed number of times. Therefore, so these type of things is called time complexity is O of 1. So this is the, we can say it's called constant time. Constant time. So we can say this one is a constant time. So this is called, so how much number of operations means how much input is we given this statement execute fixed number of time. So there is no looping here, right? There is no looping. These statements are into a equal to b, into b equal to c equal to a plus b. This is called the constant time. So input size enta perigina, the operation count almost same, that is an O of 1. We can say it is an O of 1. Next we will discuss about the linear time. Let me remove, otherwise we have space here. So we can say linear time. So we can say linear time means, what is the number of input size is equal to the number of operations. Suppose if I have a for loop, I take an example. Okay. Let me wait for 1 second. I will take the color. So for int I equal to 0, I less than n. N means here input size. I equal to 0, I less than n, I less than n, and then I plus plus. So for this kind of operations, I'm just giving a system.out.println I. So if you see this, for this operation, how many times the loop will execute? Suppose if I given n equal to 1, how many times it is executed? Loop 1 time. Suppose if I give n equal to 2, how many times it will execute? 2 times. So loop, suppose if I give n equal to 100, how many times the loop will execute? 100 times. So the loop count is linear with the input size, right? So that's why we call it as a time complexity is in O of n. So mainly here based on the input size, how much time it operation is growing. Means here see, if we give 2, operation is growing 2 times, 3 times, 4 times. So that's why we can say it is an O of n. So you can say linear time. Okay. Next, suppose in the same example you can take. So inside we have one more for loop. Inside we have one more for loop. I can say int j equal to 0, j less than n, j plus plus. Suppose if I have one more for loop here, so if I have one more for loop, how many times loop will be executed? See, it's double, right? If see, first suppose if n equal to 10, so if suppose if n equal, suppose if n equal to 10, so first time outer loop will run 10 times, second loop will also for each element 10 times. So how many times loop will execute? 10 into 10 equal to 100. Okay, right? Suppose if it is an so 10 into 10, 100. Okay, suppose if it is suppose if it is 100, so if we give input element as 100, 100 into 100, it is 10,000. So if you see the number of iterations, if you see for input size n, n into n, n into n equal to n square. So therefore we can say it as this one is a quadratic time. Okay, so we can say O of n square. Okay, this is a n square 2. Okay, you can say it as a quadratic time. So nested loop usually multiply the complexities, right? So suppose if we have one more loop inside, we can say it as O of n cube. Okay, so time complexity is measured is like this. Okay, so next we will go to the other logarithmic time. So I will remove this. Next is our logarithmic time. So logarithmic time means we can say as O of log n. We can say as L logarithmic time. So me logarithmic time. So means, suppose if we consider the binary search. Binary search means how we will search in binary search. So first time if we have n elements, next time it will become n by 2. So we will off and then again n by 4. So like this, suppose if we have input size 8, so in binary search what we will do, first we will partition into two parts, right, by taking the mid element. So next time how much what is the n value 4, then next how much the n value 2, so it will be half, right. Next how much the n value equal to 1. So it each step the reduce the search space by half. So each step the searching is half, right. So that's why we can say it as a o log n, logarithmic n. So if every time if input size is reducing by half, we can say it as a logarithmic time. This is the time complexity thing. Okay, logarithmic time. So next what we will have, this is called, you understand this, that is logarithmic time. Next we will this o n log n. Here see, so we will commonly see this efficient sorting algorithm is like in, suppose if you have any merge sort, any sorting techniques, normally